Hello, today we are simplifying radical expressions. So to warm up, we want to practice our perfect squares. So we have 1, 4, which, right, that's 2 squared. 3 squared, 4 squared, 5 squared, 36, 49, then 8 times 8, 64, 81, 100, 121, and then 144. We also can do the same thing with our variables, with exponents. We've got x to the second, to the fourth, to the sixth, to the eighth, and to the 10th. All right, so where was I? X to the 10th. If you notice the pattern, the exponents, they all are even, and they would be considered perfect squares. Okay, so let's just simplify, like, well, square root of 25 is 5, because our 5 squared equals 25. So we'll just go through these. This is because 6 squared is 36. So now, without showing all that work, just the square root of 100 would be 10, and square root of 49 would be 7. Same thing with our letters here, with our exponents. Remember the power rule from the other day? It's a to the third because of a to the third raised to the second power. And when you multiply, you'll get 6. So this would be m to the 8th raised to the second. It's going to be m to the 16th. But if you notice, it's a little shortcut. You can divide the exponent by 2. So using that, this would quickly become y to the 5th, and that would just be a. All right, let's get to simplifying perfect squares. Well, let's go through these quick. Square root of 4, 2. Square root of 16 is 4. Even if you have a negative in it in front, just bring that down. It wants the negative 10. Our letters, you are just going to take half, right? Cut that exponent in half. So then this would be w to the 6th. When you start having more than 1, just take each letter at a time. It's going to be 3, cut it in half, right? 10 in half is 5. Do the square root of 9 first, and then bring the letter down. Same thing here is bring the negative down, then do the square root of 81, and then m. Same thing, 7, a squared, b to the 6th. And then keep going, 11x to the 7th, y to the 3rd. All right, now we are going to simplify radicals that are not perfect squares. So here you want to find one perfect square, the highest one, that can go into the number. So here we have the square root of 20, and then the highest perfect square would be 4 times 5, and then the square root of 4 is 2, and then you just bring the square root of 5 down. You could read the next 2, but I'll show you number 4. So here you want to try to use 9 and 5, and then the square root of 9 is 3, and then the square root of 5 just stays. For 12, you want to use 4 and 3. Square root of 4 is 2, radical 3. And then 50, you want to use 25 and 2. You might be tempted to use 5 and 10, but neither are perfect squares. So then you got 5 times the square root of 2. Okay. When you're doing the letters, the easiest thing for the letters that are not perfect squares is to subtract 1. So I break it up. So I have a to the 4th and a to the 1st. And then the a to the 4th becomes a squared. And you're left over with one letter under the radical. So here I do 9 minus 1. So that would give me x to the 8th and then x to the 1st. Together it should add up to 9. And x to the 8th would be x to the 4th. And then I have an extra x underneath it. So this one, without showing any work, right, you would have 2 and then x to the 1st. The even one you can pull out. The odd one stays under. Okay, so I'm going to show some of these. All right, here we go. So 18, right? Square root of 9 times the square root of 2. This will be 3 square root of 2. 125, you want to try to think of the highest number that could go into, I'll do another one. All right, now I'm going to jump to number 8, where you have numbers with letters. So here you just got to be really careful. You start off with the 75, which is going to be 25 and 3, right? Because it's 3 quarters, give you 75 cents. Then you do your letters. I want a 6, and then to the first power, because that's going to give you x to the 7. Then I do my y's, y to the 4th and y to the 1st. I'm going to circle all the ones that are perfect squares. Those come out from the radical. So you're going to have 5, right? X to the 3rd, y to the 2nd, because you want to cut them in half. Everything else stays under the radical. 3x, y. All right, so let's try, we'll try number 10, right? So square root of 32 should be 16 and 2, right? 6 times 2 is 12. Now the a has an odd exponent, so I want to break it up to an even and an odd, right? So 6 plus 1 is 7. The b, though, to the 4th, that's already even. So I'm going to leave it because I'm going to circle all our perfect squares. And now I can answer them out. I have 4, right? Square root of 16. A to the 6th will be a to the 3rd. And b to the 4th will be b squared. Everything else stays under, which is the 2 and an a. And you should be done. And then you just got to be careful. If you see even exponents, that means you can do them right away. Like over here on number 11, square root of 9 is 3. And that's going to be a to the 4th. 17 has a 1 there, right? So that guy you can't even do anything with. But you can look at 63, which should be the square root of 9 times the square root of 7. And then x to the 4th I want to break up. No, I don't. That's actually a perfect square. Woohoo! It's the y one you can't touch. So I'm still going to bring it down for right now. And then I'm going to circle my perfect squares. Square root of 9 is 3. This will become x squared. Everything else will stay under.